Okay, we are doing 5.4 today, and it deals with graphing functions again. So, um, this question says, use the graph to find the following. If there's more than one answer, separate them with commas. So, when we talk about maximums and minimums, we're looking at the y values. How tall does the graph get, and how low does the graph get? So in this particular graph, this is a maximum. Okay, and the maximum value is y equals 3. What about a minimum value? What's the lowest point this graph reaches? No. It does go below negative 3. It goes all the way down to negative infinity. So this particular function has a maximum at 3, and it has no minimum, because it goes down forever. But we do have these points that are referred to as local maximums and local minimums, which means that's the smallest number in that small little general area. Okay? So we would say the maximum of this graph is y equals 3, but it does have a local maximum at y equals 2, and it also has a local minimum at y equals negative 3. Those are not maximums and minimums, but they're the biggest number in that area, or the smallest number in that area. Does that make sense? Okay. Well, if it happened in the same place, or if there's more than one. So this is saying find all values at which g has a local maximum. So where are there local maximums? At 2, and it might want us to say 3 as well, because 3 is a local maximum. It is the overall maximum. So let's try this. So let's try 3, 2. No, a max is anywhere that has a high point. And then, oh, it wants the x values here. So it says, where are there local maximums? So, so at 2 and at 4, there are local maximums. I think that's what it's asking. So let's say 2, 4. And then what are the maximums? Maybe. The maximums are at 3 and at 2. Those are the x's. So it's saying where, oh, it's negative 2. Yeah, I'll fix that. Thank you. So where do they occur? They occur at x equals negative 2 and x equals 4. And what are they? 3 and 2. So I need to make that negative. Yeah, I think. Okay. All right, question 2. All right. So we need to pick the graph that represents Jim stays in New York instead of flying to Texas. So which graph represents him staying in New York and not going to Texas? So if he stays in New York, is he getting closer to Texas over time, further from Texas over time? This graph, which it's got to be the last one. Yeah, it can't be a vertical line. That's not a function, right? So let's do another one of these. Oh, answer all the questions. Oh. At the end of a race, a runner slows down. So over time, his speed is going down, so it would be the first one. Okay, let's try another one of these. Tammy drives at a constant speed for a while. The third one. Kira goes from her house to the store. Well, it depends. The y-axis says Kira's distance from her house. So as she drives to the store, what happens to her distance from the house? Gets further away, which means it's going to be this one. Okay. Number 3. Laura is delivering a pizza to Mark's house. She drives at a constant speed toward the house until she hits a traffic jam and has to stop for several minutes. After she starts up again, she drives at a faster speed than before. So she's going to get closer to Mark's house, and then she's going to stop, and then she's going to drive even faster to get to Mark's house. So as she drives to Mark's house, is she going to get closer or further away? Closer. The third one. So right here, as time goes on, she gets closer to Mark's house. But then she gets stuck in traffic. And right here, even though time is moving forward, she's not getting any closer. And then this is her going closer to Mark's house. How can you tell she's going faster? It's steeper. Good. Okay. Laura begins her jogging workout by running faster and faster for about a minute. Once she hits a comfortable pace, she runs at that pace for several minutes. Then she gradually slows down to stop over the next few minutes. Third one, how come? So this is not distance, it's speed. So this says her speed is going up pretty quickly. And then she's still running, but her speed is constant. She stays the same speed, and then she starts slowing down until she stops. Okay? All right, number 4. Okay, do you guys remember how to graph these? So this is mx plus b. B is the y-intercept. So this hits the y-axis at -5. And then the slope is 4 over 1. So we go up 4 and over 1. And then we connect the dots. You guys remember that? What if it said -2/3 x plus 1? We start at y equals 1, and then the slope would be down 2 and over 3. It would look like that. All right, number 5. Oh, same thing. So we would start up 7, down 2, right 3. Well, we're getting ready to do something else. Okay, so average rate of change. So, um, if I had a graph that looked something like this, and I wanted to know if this is the speed of a car or the distance traveled by a car, and I want to know the average rate of change, I want to know the slope between those 2 points. Okay? So, this is kind of let's do a different example. Let's say you drive to Price in your car, and here's your speed. Right? You go through Huntington, you run into some slow cars, you drive really fast for a while, and then you get to Price. Okay? And I want to know, what was your average speed between Huntington and Price? Okay? Or you want to know your average speed from here to here. Well, you drove all sorts of speeds, right? As you were coming out of Huntington, as you came out of Huntington, you sped up until you hit that one car, and then you had to slow down until you could pass it. Then you drove like crazy, and then you kept that speed up, and then you enter Price city limits. So what is your average speed? And some of you have cars that will figure that out. You guys aren't driving yet, but there are some cars that will do like average miles per gallon, average speed, and all of that. How do you find the average speed? Well, you could take all of the speeds you drove, add them all together, and then divide by the number of speeds you have. But how many speeds did you travel? An infinite number, right? So I guess you could take your speed every second and then average them, but there's a much easier way to do it. All you have to do is find the slope between those 2 points. That's it. So the slope between those 2 points will be your average rate of speed. Sometimes, some parts you're going faster than that, some parts you're going slower than that, but when you average it all out, that will be your average speed. Does that make sense? So, how do we get that? Well, slope is y2 minus y1 over x2 minus x1. So, I need to plug in my x's. So I get 9 minus 12 plus 1. And that would be negative 2. So I'm plugging my 3 in here and in here. Yeah, we will. So when I plug in 3, I get negative 2. Okay, what happens when I plug in 7? So plug in 7, I get 49 minus 28 plus 1. So that's 49 minus 27 is 22. Okay? Well, these are my points, so I'm just going to plug them into this formula. So y2, 22, minus negative 2 is positive 20, divided by x2, 7 minus 3, is 4. So my average speed would be 5 miles an hour. I think. Let's try it. Uh-oh. Okay. I know what I did wrong. 22 minus negative 2 is 24. And then 7 minus 3 is 4. So the answer is 6. I just added those wrong. Do you guys want to see another one of those? Okay. So this is the graph that you're going to follow. This is basically your speed on your way to Price or wherever you're going. So I want to know what happens 3 minutes in. How fast are you going in 3 minutes? And then in 6 minutes, how fast will you be going? So we plug 3 in. So negative 3 squared plus 15 plus 2 is 8. So 3 minutes into your drive, you were going 8 miles an hour. And 6 minutes into your drive, you are going backwards 4 miles an hour. Okay? So if you were to take the average speed during that time, how fast were you traveling on average? So we do y2 minus y1 over x2 minus x1. So negative 4 minus 8 is negative 12. And 6 minus 3 is 3. So we get negative 4 miles an hour. Okay? Maybe this will help a little bit. You guys know the story of the tortoise and the hare? Okay. So, this is the start of the race. And this is the end of the race. And what did the hare do during this race? He went super fast, and then he stopped and took a nap. Right? And what did the tortoise do? The tortoise just went nice and steady. Okay? Well, the tortoise ended up winning because the hare was asleep. So if you were to add up all of the hare's speeds, so every second you figured out how fast the hare was running. Okay? Well, up until now, the hare was going really, really fast, but then it started going how fast? 0. So let's say each one of those is like 30 miles an hour. 30 plus 30 plus 30 plus 30 plus 30 plus 30. What happens when we get to the top? Plus 0 plus 0 plus 0 plus 0 plus 0. And then we divide that by however many minutes they were running, and you get the average speed for the hare. Okay? Well, if this is when the race ends, then the average of all of these dots is smaller than the average of all of these dots. And you can see that right here. I'm not a very good drawer. But do you see how the slope, the average slope of what the hare is doing is below the average slope of what the tortoise was doing? So it doesn't matter what happens over here. If you look at this point and this point, all you have to do is find the slope, and that will tell you the average speed. Instead of adding up all of those individual speeds along the way, if you take the first speed and the last speed and you take the average, that will tell you, you find the slope, that will tell you the average speed. Okay? And in that race, even though the hare went really, really fast at the beginning, the average speed is below the average speed of the tortoise because the hare took a nap and you have all those zeros. Okay, and this one. Okay, find the average rate of change from -7 to -5. This is actually easier than the past problem. So at -7, we have this point right here. So -7 comma -9, positive 9. Okay. And then -5 comma 3. What is the average rate of change? Well, it's just the slope right here. So we could plug it into the formula, or we could just count down 1, 2, 3, 4, 5, 6 over 2. So down 6 over 2 is the same as negative 3. Right here. I looked at, it told me which x's to use, and then I put those x's on the graph, and that told me where the y's were. It tells you which two to pick. Right here it told me use x is negative 7 and x is negative 5. So I don't know why those are there. They don't do anything in this. But it said use this number and use this number. So then on the graph I had to figure out where those points were. Then I just counted. Down 6 and over 2. Yeah. Yeah, if they give you the graph, it's much easier. It's the same problem that we had before, but this time we had a graph to look at. I think that's everything. Let's look. Yep. Okay. Get to work. If you need help, come up and see me.